Students, now I am solving the problem on properties of systems. Here the question is, for the following continuous time systems, determine whether the system is linear, time invariant, memoryless, causal and stable. There are four questions I have taken here. First one is y of t is equal to x of t square. Second one is y of t is equal to t square into x of t minus 1. Y of t is equal to x square of t. And y of t is equal to differentiation of e to the power of minus t into x of t with respect to dt. First problem I have taken, that is y of t is equal to x of t square. When you do the operation on x of t, that is h indicates the operator of a system. When you do the operation on x of t, that is y of t will become x of t square. To check its linearity, that is linear and non-linear, first input signal will take x1 of t, then corresponding output is y1 of t is equal to x1 of t square. For the same continuous time system, if I take x2 of t, then output response is, the output is y2 of t is equal to x2 of t square. Next, I'll replace x of t by x1 of t plus x2 of t. Then it becomes y of t is equal to x1 of t square plus x2 of t square. Then x1 of t square is y1 of t and x2 of t square is y2 of t. Then y of t is equal to y1 of t plus y2 of t. It satisfies the principle of superposition and the system is said to be linear. Next, to check its time invariance property, let us take y of t is equal to x of t square. You know that time invariance property says that if there is a delay or advancement in the input signal, there must be a corresponding delay or advancement in the output signal also. That's why to check that, replace t by t minus t naught. Y of t minus t naught is equal to x of t minus t naught its whole square. That is, y of t minus t naught is equal to x of t minus t naught whole square is t square plus t naught square minus 2 t into t naught. Okay, that means here it is not in accordance with the input signal. Output is delayed by t naught units, but input is not delayed by t naught units. It has got t naught square minus 2 t naught into t. Okay, it has a different value. That's why it is not time invariant, it is time variant. Okay. Now let us check its, that is memory or a memoryless. Okay, we have taken that y of t is equal to x of t square. It is any value. Suppose if I take that t is equal to minus 2, y of minus 2 is equal to what you will get, that is x of minus 2 whole square, that is nothing but x of 4 will go. That is, so you are observing output at t is equal to minus 2, but it requires input of, that is x of 4, hence it is not memoryless. Okay, you can take any other value also. T is equal to 2 you can take, then it will become x of 4. T is equal to 1 you can take it, then it depends present value. T is equal to 3 also you can take. A y of 3 it will become, suppose if I take that t is equal to 3, y of 3 is equal to, we get x of 3 square, it will become 9. Okay. What is the definition of memoryless system? Any system is said to be memoryless if its output depends only on the present value of input. It is not depends upon the present value of the input, hence it is not memoryless system or memory system. It is not memoryless system. Okay. Next, causal or non-causal system. That is, to check it is a causal or non-causal, check any value of t. That is, suppose if you take that t is equal to 4, y of 4 is equal to x of 4 square is, it will become 16. It depends upon the future value of the input. So see, you are observing output at t is equal to 4, but you require what is the input at t is equal to 16, that is x of 16 is required. It is a future input and the system is said to be non-causal. You know the definition of non-causal. Any system is said to be non-causal if its output depends on the future value of the input. So it is non-causal system. Next, stability. Here system is stable because Question is y of t is equal to x of t square. If input is bounded, okay, if x of t is some value, that is bx, that is less than infinity, obviously x of t square is also that is less than infinity, and y of t is also some other value by, that is bounded output, that is less than infinity. Hence the system, since for a bounded input it gives the bounded output, the system is said to be stable. Okay, let us take the second problem. That is second problem, here it is y of t is equal to that is t square into x of t minus 1. Now first, to check the linearity, let us take that is y1 of t is equal to t square into x1 of t minus 1, y2 of t is equal to t square x2 of t minus 1. Replace x of t by x1 of t plus x2 of t. X of t is equal to x1 of t plus x2 of t. Then y of t is equal to t square. Here you have, replace x by t minus 1. Here it will become x1 of t minus 1 plus x2 of t minus 1. That is x1 of t minus 1 plus x2 of t minus 1. We'll get that is y of t is equal to t square x1 of t minus 1 plus t square, that is x2 of t minus 1. That is nothing but that is y of t is equal to y1 of t plus y2 of t, satisfying the principle of superposition, and the system is said to be linear. The system is said to be linear. Okay, I'll check for the time invariance property. That is, to check for the time invariance property, y of t is equal to t square x of t minus 1. Put t is equal to t minus t naught. That is, y of t minus t naught is equal to t minus t naught its whole square, t minus t naught its whole square, x of t minus t naught minus 1. That is, y of t minus t naught equals to y of t minus t naught equals to t minus t naught its whole square, x of t minus t naught minus 1. See here, output is delayed by t naught units, but input is delayed by t minus of t naught plus 1. That is t minus t naught whole square. This is amplitude scaling. That is t minus of t naught plus 1. Take minus common here. Input is delayed by t naught plus unit, t naught plus 1 units, whereas output is delayed by just t naught units. That means output delay in the output signal is not in accordance with the input signal, because input signal is delayed by t naught plus 1 units. Output is delayed by just t naught units, hence it is not a time invariant, or you can say that it is time variant. Okay, next, memory or a memoryless. Okay, y of t equals to t square x of t minus 1. You can take any value of t. Suppose if we take the t is equal to 1. If we take the t is equal to 1, you'll get that is y of 1 is equal to that is 1 square is 1, x of 1 minus 1 is, it will become 0. See, it is depends upon the previous value of the input. It is a memory system or not memoryless system. Okay, it is a memory because it depends upon the previous value of the input. You are observing output at t is equal to 1, but you required what is the input at t is equal to 0. It depends upon the past values of the input. It requires memory, and it is called memory system. Okay, next, causal or non-causal. y of t is equal to how, that is t square x of t minus 1. Take any value of t, t is equal to 2. If I take that, y of 2 equals to 2 square is 4, x of 2 minus 1 is 1. See, again it depends upon the previous value of the input. We know that causality condition. Any system is said to be causal if its output depends on present and or past input values. If it depends upon the future values of the input, then the system is said to be non-causal. See, here it depends upon the past values of the input, hence it is a causal system. It is a causal system. Next, stable or unstable. It is here for a bounded input, you should give a bounded output here. Okay, for example, if you have that is x of t is less than x less than infinity, if y of t is, what is the y of t here? Y of t equals to, that is t square x of t minus 1. This value is t square, will get as it is into input is bx, x of t minus 1 is also bx. As t tends to infinity, y of t will become infinity square is infinity into bx, that is answer will become infinity, hence it is unbounded system. For a bounded input, it gives an unbounded output, hence the system is said to be unstable. Okay. This completes the second problem. We go for the third one. Third one is, that is x of t square. That is y of t is equal to, sorry, x square of t. Y of t is equal to, that is x square of t. What is x square of t here? You can take, that is to check for the linearity. Y1 of t is equal to x1 square of t. Y1 of t is equal to x1 square of t. Y2 of t is equal to x2 square of t. Replace x of t by sum of the individual signals, that is x1 of t plus x2 of t. Okay, then you'll get y of t is equal to x of t, replace it by x1 of t plus x2 of t, its whole square. Okay, then becomes, that is y of t is equal to x1 square of t plus x2 square of t plus 2 into x1 of t into x2 of t, 2 into x1 of t into x2 of t. That is, y of t is equal to, y of t is not equal to y1 of t plus y2 of t, because y1 of t is x1 square of t, y2 of t is x2 square of t, but here you have plus 2 into x1 of t into x2 of t is there, hence the system is non-linear. It is not satisfying the principle of superposition. System is non-linear. Okay. Next, we'll check for the time invariance, that is y of t is equal to x square of t. Put t is equal to t minus t naught. You get y of t minus t naught is equal to x square of t minus t naught. Input is delayed by t naught units. Output is also delayed by t naught units. It is satisfying the time invariant property, hence it is time invariant system. Hence it is a time invariant system. Memory or memoryless. It is very simple. It depends only on the present value of the input. Y of t is equal to, that is x square of t. When t is equal to 1, y of 1 is equal to x square of 1. observing at t is equal to 1, it requires what is the input at t is equal to 1, hence it is a memory-less system. It is not depends upon the past values of the input. It is a memory-less system. It is a memory-less system. It is causal or non-causal. Again, it depends only on the present value of the system. That is, y of t is equal to x square of t. Take t is equal to any value. Suppose if we take the t is equal to 2, y of 2 is equal to x square of 2. It depends only on the present values of the input, and system is said to be causal. Stable or unstable. For y of t, you need a output should be less than infinity for a bounded input. Here input is x square of t. When input is bounded, output is also bounded, and the system is said to be stable. Okay. Next, we'll take the fourth problem. Fourth problem, that is y of t is equal to differentiation of e to the power of minus t e to the power of minus t into x of t. Okay. Now you can check for individual inputs. Y1 of t is equal to differentiation of e to the power of minus t into x1 of t. When input is x1 of t, output is y1 of t, that is differentiation of x1 of e to the power of minus t into x1 of t. Similarly, y2 of t, that y2 of t is equal to differentiation of e to the power of minus t x2 of t. Okay. Now, I'll replace x of t by x1 of t plus x2 of t. That is, y of t is equal to differentiation of e to the power of minus t. X of t is replaced by x1 of t plus x2 of t. That is, y of t is equal to differentiation of e to the power of minus t into x1 of t plus differentiation of e to the power of minus t into x2 of t. Okay, that is y of t is equal to, this is y1 of t plus this is y2 of t. This is y1 of t, this is y2 of t. Hence it is satisfying the principle of superposition. System is said to be linear. System is said to be linear. Next, it's time invariant or time variant. That is, y of t is equal to differentiation of e to the power of minus t x of t minus t naught. Here exponential signal is x of t. Here input exponential signal is multiplied by the x of t here. When I take t is equal to t minus t naught, okay, you get that is y of t minus t naught is equal to differentiation of e to the power of minus of t minus t naught into x of t minus t naught. X of t minus. The input is delayed. With the input, exponential signal is also changed its upper value. That is, okay, the exponential signal is also changed. Okay, and it is not matching with the, that is, input is delayed by t naught units, output is also delayed by t naught units, but with the input this is also delayed. We can say that it is an variant system, time variant. It is a time invariant system, and it is a memory or a memoryless. See, here it depends only on the present values of the input. Okay, that is y of t is equal to differentiation of e to the power of minus t into x of t. If I take t is equal to 1, y of 1 is equal to differentiation of e to the power of minus 1 into x of 1. It depends upon the only on the present values of the input, and it it is a memoryless system. Memoryless system. Next, it's causal or non-causal. Output depends only on the present value of the input. It does not depend on the future values of the input. And it is a causal system. Next, last one, stability. It is when input is bounded as t tends to infinity, this e to the power of minus infinity I'll get here. Okay, that is it becomes 0. That's why what you can say that it gives an unbounded output. Okay, system is said to be unstable. Okay, this completes all 4 problems of this question. Thank you.